look at today are the sum and difference formulas. And these are some formulas that are not part of the fundamental trig identities, but they are useful formulas. We'll look at a couple of different applications of these. But we have one for the sum or difference of angles when you're taking the sine of those angles. One for the sum or difference when you're taking the cosine. And then one for the sum or difference when you're taking the tangent. Okay, so we have three different pairs of formulas. And the key to getting these is really to understand the similarities in the formulas. Okay? So, let's take a look at the formulas, point out the similarities between the two, because there's really only, three main structures, and then if you recognize the differences between whether it's plus or minus, it makes it easier to remember. Okay? So, first of all, we have the sine of u plus v is sine of u times the cosine of v plus the cosine of u times the sine of v. So notice here, when we're taking the sine, you end up taking both the sine and the cosine of each of the angles, but it's just a matter of how you combine them. Okay? So notice it's sine u cosine v plus cosine u sine v. The only difference between this and the sine of u minus v is this sign in the middle. Okay? Instead of adding them, you'll subtract them. Okay? So, just to highlight the differences here. Okay? For addition, it's addition. For subtraction, it's subtraction. Everything else is the same in these two formulas. Okay? Now notice for the sine formula, each term is a combination. It's sine of one, cosine of the other. Okay? For the cosine formula, you'll notice here that in both cases, you're taking the cosine of each angle and multiplying it, and then you're taking the sine of each of the angles and multiplying it. And then you're going to combine those two products. With cosine, however, the cosine of the sum of two angles, you end up subtracting the sines from the cosines. When we have cosine of u minus v, you're going to take the cosines plus the sines. Okay? So again, here's a similarity, or a difference that you can notice. The sine functions, what you're doing with the angles is what you do in the formula. So, adding angles, we add. Subtracting angles, we subtract. With the cosines, we do the opposite in the formula. The cosine of u plus v, we're subtracting. The cosine of u minus v, we add in the formula. Okay? So just another helpful thing to recognize and remember to help you remember the formulas. Okay? Then you have the tangent. Okay? The tangent formula is a little more complicated, but again, the two are similar. Alright? Notice here, we have the tangent of u plus v. We'll use orange here. Okay? The tangent of u plus v. In the numerator, we have the same sign. It's tangent of u plus the tangent of v. Okay? However, the denominator has the opposite sign. Okay? Let's see. What should we use? Let's use this color, whatever that is. Well, no, that's almost the background color. Let's use that color. Okay? For u minus v, the numerator is subtraction, but now the denominator is addition. Okay? So in the tangents, the numerator has the same sign, and it's tangent u, tangent v, so tangent u plus tangent v, or tangent u minus tangent v. But the denominator has the opposite sign of what you're doing with the angles. So here it's tangent u plus v, the denominator is 1 minus tan u tan v. Here tangent of u minus v, we have 1 plus tan u tan v. Okay? So, keep an eye on those formulas. As you're using them, try to, pay attention to those similarities and differences to help you remember them, okay? So those are the formulas. Let's look at how we would go about using these, all right? One of the things that we can do is use these to find the value of trig functions that are not on our unit circle, okay? Let me blow this. There we go. Oh, no, stop. There we go. Okay, it's just going crazy here. Let's do it this way. Page width. There we go. Okay, so you can see a little better. Find the exact value of cosine of 75. Now, in order to do this, we need to write this as the cosine of a combination of two angles.
45 plus 30.
Okay, there we go. There's two angles on the unit circle, 45 degrees plus 30 degrees.
You also do a subtraction one too if you wanted to.
You could, if you saw one of those, like maybe a 120 minus, 120 minus,
45.
oh yeah, 45. So 120 minus 45 would work here. You could use the subtraction formula. Okay, but here we have cosine of 45 plus 30. So we go back and look at this. Cosine of u plus v is cosine u cosine v minus sine u sine v. Okay? Let's write this here so we remember. Cosine of u plus v is cosine times cosine minus sine times sine. Okay? So there's the formula that we're going to use. So now it's just a matter of plugging it in properly. Okay? So, cosine of u plus v, we have 45 plus 30. So this is going to equal the cosine of 45 times the cosine of 30 minus the sine of 45 times the sine of 30. Okay? Does everyone follow what I did there? Okay? Not too hard. Now it's just a matter of remembering our unit circle. So cosine of 45 is?
Root 2 over 2.
Root 2 over 2. Cosine of 30 is? Good. Root 3 over 2. Minus, what's sine of 45?
Root 2 over 2.
Good. Root 2 over 2. And sine of 30 is? 1/2. Alright, so if we simplify here, we have the square root of 6 over 4 minus the square root of 2 over 4. And the only thing that we can do with that is simply write our final answer as the square root of 6 minus the square root of 2 all over 4. And we would leave it like that because they ask for an exact value. That means leave it in radical form. Don't get a decimal and round. Okay?
Wait, isn't it the square root of 2 over 2?
No, because you multiply by a half.
Never mind.
So, that makes sense so far?
Yes.
Okay? Alright, let's try another one here. We want the sine of pi over 12. Now I will tell you The radian ones are a little more challenging to figure out which two angles we're using. Because you got to think common denominators and stuff like that. Alright, so let's think about this. If I want the sine of pi over 12.
Pi over 3, pi over 4.
Okay, if we use pi over 3 and pi over 4, those have a common denominator of 12, right?
Yeah.
So now we've got to figure out, okay, I want it positive pi over 12, but pi over 12 is smaller than pi over 4 or pi over 3, right? So we're going to have to do subtraction,
Pi over 4.
which is going to come first.
Pi over 4. 3.
3, yeah.
Pi over 3. Pi over 3 is bigger, right? We want a positive. So yeah, good. This is pi over 3 minus pi over 4. Very good.
Gotcha.
Okay? So now we have to use our formula. And the formula for the sine of u minus v, remember, is sine u times cosine v. And it's the same sign as what's in here, so minus cosine u times sine of v. Okay?
Sweet.
So now it's just a matter of plugging it in. We actually already did the hard part. We figured out what two angles we're using, and we remembered the formula. Now it's just a matter of plugging it in. So we're doing the sine of pi over 3, which, by the way, is what? Root 3 over 2. We'll fill it in as we go. Times the cosine of pi over 4.
Root 2 over 2.
Good, root 2 over 2. Minus cosine of pi over 3, which is 1/2, times the sine of pi over 4, which equals root 2 over 2. So we simplify this, and they're both going to be over 4, so I'll put the whole thing over 4.
The same answer for the stop to the other one.
Yeah, root 6 minus root 2. Now, not every problem turns out to be root 6 minus root 2 over 4.
Oh, crazy.
But these two actually do. So the sine of pi over 12 is the same thing as the cosine of 75. Which, if you converted this to radians, or to degrees, this is actually 15 degrees. Right? So,
Oh,
sine of 15 equals the cosine of 75, right?
Yeah, together.
Yeah.
Alright. What are those? Cofunctions. Alright? Okay, so, does that make sense using the formula?
Yeah.
Alright? The radian ones can be tricky, but just think common denominator. That'll help you get the right reference angles. Okay? Alright, let's try another one here. Okay? We want to find the exact value of sine u plus v given this information. Alright?
Oh,
So, we don't know what u and v are.
is it like working backwards?
Okay? But we do know what the sine and cosine are. Now, you'll notice here we have a range from 0 to pi over 2, and we have a range from pi over 2 to pi.
So those are two different quadrants.
Okay? Well, that's okay. U is an acute angle. V happens to be an obtuse angle. Alright? And that's okay. All we need to do here is use our formula. The sine of u plus v, we're going to use the sine of u, use in parentheses, sine of u times cosine of v plus cosine of u times the sine of v. And all we have to do here is we got to plug it in. Okay? Sine of u is 4/5, like they tell us. Cosine of v equals
Negative 12 over 13.
-12 over 13. Okay? Now, here's where it can be a little challenging because we want sine, or we need the cosine of u, but all we know is the sine of u. So what do we have to do?
Function identities.
Put Pythagorean theorem.
-1.
We could use the Pythagorean identities, okay? If we use the Pythagorean identity, we know sine squared u plus cosine squared u equals 1. Well, sine squared u is 16/25. Alright? We subtract, and that's 9/25. So what is cosine? And it could be plus or minus 3/5, right? Because, okay. But, wait, what'd you say?
First quadrant.
It's in the first quadrant, right? So which is it? Plus or minus 3/5?
Plus.
It's plus 3/5. Alright, so now we know what goes in here. It's plus 3/5. Everyone with me on this? Alright, so then we have to do the same thing to figure out what the sine of v is. Okay? Now, notice if we're in the second quadrant, what do I know about the sine of v?
It's gonna be
Positive.
positive.
It's going to be positive. Alright, so that's nice. So we know it's going to be positive. Again, we're going to do this whole thing except
V.
we're dealing with v's. Alright, so here's v and v. Alright? So cosine is -12/13. So when we square that, it's 144 over 169. So I know sine squared of v, if I subtract, is going to be 25 over 169. So sine is
5/13.
5/13. Good. Alright, so we plug that in. We've got 5/13. Don't forget you can reduce before you multiply if you want. Although, so like we could cross out the 5s. Although leaving the 5 there would give us a common denominator of 65. So I'm not going to reduce. I have a -48 plus 15 over -65. -33/65, and I don't think that reduces because that's 13 times 5, and that's not divisible by 13 or 5. So, there you have it. Okay? So you see here how, again, every problem's kind of a little puzzle that you got to figure out. Everyone has its own little nuance, and you got to keep in mind the identities and everything else, all right? So, now, one last one here as an example. Wait. Yeah. Okay. This is kind of an interesting one here. The cosine of arctangent of 1 plus the arc cosine of x.
Can you simplify what's in there first?
What could we simplify?
Right, if it's
Can you convert to
arc
Cosine.
tangent is cosine over sine.
Wait. What? Arctangent is what?
Cosine.
sine over
Cosine equal x.
sine over.
For this.
Wait. Well, don't we know what tangent are?
Could we simplify anything in there?
I don't think so.
What's arctangent of 1?
We multiply the cosine with u and v, and then we can
Hang on, what, see?
Never mind.
Multiply the cosine of u and the cosine of v. Oh, we will do that eventually. We know what arctangent of 1 is, though, right?
Yeah.
Yeah,
Oh,
isn't
it's
it
45.
0 or pi?
No.
45?
What?
45.
It's a 45 or the pi over 4.
So
Although there's two different quadrants that could go in, right?
Yeah, first
First or
and
third.
third.
And there's nothing in here that really identifies where we should be.
Yeah.
So let's, before we try dealing with that, let's try putting some things into our formula. And we may have to consider two different cases. Okay? The case where we're in the first quadrant and the case where we're in the third quadrant. Alright? So let's try this. Cosine of u plus v is cosine u cosine v. So we have cosine of the arctan of 1 times the cosine of the arccosine of x. Alright? Minus, move this down a little bit, minus the sine of u. So we have the sine of the arctan of 1 times the sine of the arc cosine of x. Okay? Well, let's see what we can do with this at this point. Alright? Now, it says we're going to have an algebraic expression, so we're not going to be able to get down to just a 1. Alright? What's one thing that I can simplify, though?
cosine or cosine of x?
Cosine of arc cosine, what does that give us?
1.
X.
X,
Oh,
okay? That gives us x. So right here, that whole thing is x. Now, the other thing that we can do is we can consider two cases. All right? So first case is when our if our u is in the first quadrant, okay? Arctangent of 1 would then equal what if we're in the first quadrant?
45 or pi over 4.
Pi over 4. So we would have the cosine of pi over 4 times the x minus the sine of pi over 4 times the sine of arc cosine of x. And guys, there's nothing really that we're going to be able to do with this. Okay? But we can simplify these now. Alright? We have root 2 over 2. So it's x root 2 over 2. This is going to be root 2 over 2 as well. So since this part is all over 2, I'm going to make it minus the root 2, and then you just have the times the sine of arc cosine x. Okay? They were both over 2, so we made it one big fraction. Alright, so does that make sense?
Yep.
Alright. The second case,
Wait, how'd you get the pi over 4? What'd you do with the root 2 over 2?
sine of this is root 2 over 2, so I had root 2 times this over 2. And since I had a common denominator with the first half, I just put it all in one big fraction.
So, because cosine of pi over 4 was root 2 over 2, that's why.
Yeah, I have this.
Hi.
Hi.
We have a candy jam for Carly Goldberg.
Oh, here she is.
Thank you.
Alright. Thank you.
Sorry for interrupting.
Oh, not a problem.
They asked me if there's anyone who's
Those middle schoolers, they're always like scared to death.
They asked me if there's anyone who's CG.
I don't know who this is.
Okay. Alright, so this is what we have, and then I just combine it into one big fraction all over 2. Okay? Now, the alternative here, guys, the other case is if U is in the third quadrant. Okay? The only difference here is that when I take the cosine of pi over 4, I'll get a negative root 2 over 2. And when I do the sine of pi over 4, I'll get a negative root 2 over 2. So what ends up happening here, okay, I actually have, let me do this to save some writing. Okay. Instead of just a pi over 4, where would I be in the third quadrant?
Yeah.
5 pi over 4. Okay, for both of these. And then that would make this a negative, and that would make this
Positives.
a plus. Okay? So that's the only difference between the two. Okay? So we have 2 possibilities there.
Cool, cool.
Any questions?
I have a question.
Yes.
Like I don't know whether cosine multiply r cosine x is equal to x.
Oh, why this?
Yeah.
Well, these are inverse functions. And remember the definition of an inverse function, the inverse of the function will always get you back to x. Okay? In other words, if f of x equals, let's say, a number c,
64.
then if I take the inverse of c,
1 over c.
it'll get me back to x. Alright, so f will take x over here to c. F inverse takes c back where we started to x. Okay?
Okay.
So that's why. These are just inverse functions. Any other questions? All right. So, I've got a little, I want you to just, in the time we have left here, we can get started on this, but here are some that use sine and cosine. They've already broken up the angles. And also notice here the A and B. This is just kind of a few proofs to show that you can't just distribute the sign, okay? This isn't multiplication, so you wouldn't distribute anyways. But this is what people often will say. They want to try to do. Oh, sine of 2 pi over 3 plus 5 pi over 6 must be the sine of 2 pi over 3 plus the sine of 5 pi over 6. It doesn't work that way. That's why we have this formula that we were looking at today. Alright, so here you can look at both of these values and see, yeah, those are totally different values in the end. Okay? So I'm going to let you get started with that in the time that we have left. And you guys can finish for Tuesday. Alright?
Do you know